Hey folks, I wanted to take some time to demonstrate our new plugin for the 3D animation program called Blender. Blender is a free and open source tool that's been in development for decades, but up until now there's been no way to go directly from Blender into Laser. Now what we're releasing today is an add-on that is a real-time renderer where you go directly and instantly from Blender into Laser. There are no intermediate steps or additional programs needed. In addition to the native 3D capabilities of Blender and our plugin, this combination of tools provides a new way to create 2D artwork, and indeed a new way to work with BeamBrush, and I'm going to be demonstrating this. This new Blender plugin uses the same familiar workflow as used in our plugins for 3D Studio Max, Cinema 4D, and Beyond 3D, so anyone who's used those will be able to just jump right in and get started. And finally, this plugin is included free with all levels of Beyond, including Essentials. Now this is something we've been working on for around a year, and the whole team has been involved. Vladimir, who's our main programmer on this project, has really put his heart and soul into it, so we've created a true world-class product. We've released several builds of this, and during the development we've sought the input from several artists around the world to give us feedback on the plugin and to see how they would use it. And we are including a lot of their artwork for free along with the plugin installation. I think you're going to like what you see. Now this is going to be a long form video that will cover everything from downloading Blender, the installation of the plugin, and I'll be showing and demonstrating the files that we're including. And there's one very exciting and brand new feature that we just worked into the plugin in the last few days, so I hope you'll watch to the end. Nevertheless, we will include timestamps so you can go directly to your area of interest. Now, without further ado, let me just jump right behind the computer and show you what we got going on. All right, the very first thing I'm going to demonstrate is where to find the installer for the plugin. It's loaded where you've installed Beyond. So we'll go to C, Beyond 52, and this folder here called Install Support is where all of our plugin installers are. We'll go directly here to LC Blender Installer, and this is where the installer is located. Now, I'm not going to do anything with this, but there's a method to my madness here that bringing this window up before everything else, because this tells you the versions of Blender that are supported by this installer, which is 3.3 through 3.5. So once we got this window open and we see the versions that are supported, we can go to the Blender website. Blender could be downloaded for free. You just go to blender.org. And here we go. The very first page we come to shows this nice bright blue big button that says download now. Now you may be tempted to click on that button and download the version since that's what it says. But there is a caveat to this, which is that Blender is being developed all the time. I mean, it's amazing how quickly they come out with new versions. Probably by the time you watch this video, they'll be up to 3.7 or 4.0 even. And so that was really the point of looking at the versions that we actually support. So if they're on version 3.6 and our installer only supports up to version 3.5, this is what you do. You go to support, you go to download, and then this area here called long-term support. When you go here, you'll find versions that are going to be around for a long time. So you see this Blender 3.3 LTS. This is going to be available until September into 2024. And so if there's a particular version of Blender that's higher than the highest version that we support, just go to the long-term support and download this one. Otherwise, in this case, it said that 3.5 was available. Just click download, and you can just click on that and it will automatically download. So I've actually already downloaded Blender, and so I'm not going to go through that process of downloading and installing. I've already have it installed here. So once you do install it, I would recommend going ahead and starting it just to make sure that the installation works. It should come up to this window right here, and once it does, I would recommend just exiting at this point. So then you can, once Blender is installed and operational, you can install the plugin. You just leave this window open and double click on this. Here's the license agreement. You must read and accept the terms of the license agreement. This will tell you the version of Blender that will be installed by the installer. If you have multiple versions of Blender that are supported by the installer, you'll see multiple things here with check marks. Just click Next. And once again, I've actually already installed Lasershow Converter Blender, so I'm not going to click the Install button, but this is how you do it. So the next thing I'd recommend you do is start Beyond, because the plugin works with Beyond. If Beyond isn't running at the time you start Blender and the plugin, it will tell you that you need to start Beyond first. So Beyond is here and running. And the way that these plugins work in our 3D Studio Max plugin and our Beyond 3D is you click on the cue where you want the animation to go. So I'm just going to click down here. We'll minimize Beyond and then start Blender. And what I'm going to be covering right now is how to kind of activate our plugin within Blender. So what you do is come up here to Edit, then Preferences. And if you scroll here, the plugin is that they're all in alphabetical order, but there is a quick way to find our plugin, and that's just to go over here and say that you want to see all the renderers. And here it is, it's Lasershow Converter Blender, and when you put the check mark next to Lasershow Converter Blender, it will install and activate the plugin for you. What you can do is click this down arrow, and you can see that this is where you can find the documentation. It just takes you right to the wiki, pangolin.com, that is regarding Lasershow Converter Blender, which covers everything that I'm talking about right now, including how to install it and run it. There are also buttons here to report a bug or to remove the plugin. I suspect that you'll use these two very rarely. This tells you the version of the plugin, but the version is also shown in our preview window that I'll be demonstrating now. Nevertheless, this is it. The plugin is installed and running. So if I come over here to the Render tab, what I'll do just to demonstrate this is click on Render Image, and what you see is a huge window open up where it shows the rendered result from Blender. And so one very good idea would be to make that window smaller. So we're working with lasers. 320 by 320 or 400 by 400 is a good size. I'll just try that again. So you can see a much smaller window pop up with the rendered result. If we want to see this in laser, we'll just come over here to the Render Properties tab and select Lasershow Converter as the renderer. And really, that's all you need to do to get started. There it is. Let's see. Here are all of the settings for Lasershow Converter Blender. One of the things that we want to do is automatically send frames to Beyond after it's rendered. Sometimes we want to do this, sometimes not. I'll demonstrate this here in a second. So there it is in Beyond. I'll enable laser output. Come back to Blender. Actually, maybe what I'll do is select the next cue. So I want the animation to go into the next cue. I'll come back to Blender. So now let's create a little scene. In preparation for this, I'll click on the camera view so that I can work directly with the output that's going to go to the laser and tell them that I want to see the shaded output. So what I'm going to do is start by changing the material on this cube to be red instead of white. Just make it a little bit more interesting to show that. There it is, red and laser. So we'll create a little scene here. I'll click on the Move tool and move this cube to an initial position. Click on the object settings and just move and make a keyframe in that position. I'll move the time slider to a different time, drag the cube to a different location, and make a keyframe in this location, and repeat this several times, just as a demonstration of how to do things. Now what I'll do is go back to the original position, and what you can see is now as I move the time slider, we've created a little animation in terms of the position. what I'll do is say I want that to be an initial rotation angle, and maybe come over here and change the rotation angle. And we'll make that a new rotation angle, at this position in time. So what we see is we create a little animation here, and I'll click Render Animation, and it renders out to the laser instantly. So with this, I'll discuss a few of the options here in the Lasershow Converter Blender settings. We have this very first one I'm going to cover is this thing called interactive rendering. Now this is sort of like real-time rendering, but it only works for options within the plugin, and I'll show you what I mean by that here in a second. So what I can do is this controls kind of the main render settings, the top level stuff that happens, and all of the actual options for how you render these objects is in this. It's called default settings. Now I'm not going to cover all of these in detail in this video because the line types, filter settings, color settings, point placement, soft line beam brush, all of this works exactly the same as it does in our plugins for 3D Studio Max and our Beyond 3D program. And so I'm not going to go into these in depth. And so if you want to learn about these, you can watch our tutorial videos. Probably the best one would be on Beyond 3D. But I will demonstrate, since we've checked interactive rendering, I will go ahead and just kind of poke around and change a few things on this just to demonstrate how this interactive rendering works. So for example, if I turn this off, you can see the difference. If I say all polygon lines, it adds some. If I say if we want to put contours on there, we could change the contour axis. We can come down here, select a different color for the cube. We want to override the color with something else. And what it means, that interactive rendering, is anything that we do in the plugin is instant, and you do not need to go up there and say render. Now unfortunately, if I change something here in Blender, such as the angle of this cube, this does not instantly create a rendering action on the renderer, and this is because Blender does not send us messages telling us that something within the Blender environment has changed. And so we hope that this happens sometime in the future, and if it does, we will change the name of this checkbox to real-time rendering, as it is in our other products. So unfortunately, we can only do the changes within our plugin, and that's why we called it interactive rendering. And just so once again, I'll just kind of render this whole animation just to show. There we go. And what I'm going to do too is open up a preview window. We have our own preview window in Lasershow Converter Blender, and it's kind of better than the Blender preview window for a few reasons that will become obvious as I get into this tutorial. But just know that you can open up this preview window. It works in real time. It really faithfully shows what's going to be projected on the laser, and gives you some additional information such as the laser frame number, the number of points involved, and so forth. So once we're done here, what we could do is say send frames to beyond, and if I come over here to beyond, what you'll see is that the animation is exactly where we told it to be in the cue that we clicked. So I'm going to click blackout and choose another cue here in beyond. We'll come back to Blender. And so that kind of gives you a high-level view of these options. Now with that demonstration having been done, what I'm going to be doing is going through some of the scenes that we are including along with the installations. These scenes were developed, some of them by us, but mostly by the artists that we've had testing and playing around with the plugin during the development. So to find these example files, what you do is come up here to say File, Open, and then click on the Documents folder. And when you come up to Documents, this is your Documents folder. And Blender automatically puts a folder in the Documents. And what you'll notice is that we have created Pangolin LC Blender examples within this Documents folder. So I'll double click this. And here are all of the examples that we are including. Now you'll notice some numbers next to it. These numbers will not show up in your files. These are a cue to me to demonstrate things step by step. But you're going to see the file names will be there in yours, but the numbers will not be. So the very first thing I'm going to demonstrate is something called Freestyle. Anybody who's used Laser along with Blender up until now has been using something called Freestyle. I'll just go ahead and render this just to demonstrate it. What Freestyle is a built-in line renderer in Blender. This is a built-in capability in Blender. And it basically just turns the objects into lines. What most laser people have done up until now is take the lines that are developed by Freestyle, and then they take those lines and export them with a separate program into Laser. And so we have included that capability with our plugin, and how it works is here in what we call the default settings. The render source can be Freestyle strokes, or the render source can be geometric objects. Geometric objects, when you use this, it's using our renderer, and you have all of these options and just a whole lot of control over how things are rendered. And alternatively, you can say you want Freestyle strokes, in which case it's Freestyle that's determining what is being output. And so Freestyle is slower, and it also doesn't have as many rendering options as ours, but nevertheless, during the development, we found that some people liked what Freestyle did, so we have this as an option. So I'm going to load another file here that demonstrates Freestyle to demonstrate a few different aspects of this. Now I'll go ahead and render this. This is a kind of classic thing. This is a classic scene that we have developed way back in the year 2000 when we came out with our plugin for 3D Studio Max. So some of you may recognize this scene. You know, and once it's rendered, we can move the frame slider and just see the rendered frames here. Now the point is, I want you to see, we'll do that again just to see how quickly or slowly the rendering action is. You see, this is how fast it's going. I'll hit escape just to stop the rendering process. Close this window, because when I turn off Freestyle, actually what I'm going to do first is say that we want our rendering source to be the geometric objects instead of Freestyle, in which case now we have some additional capabilities that we have in our renderer. But I'll go ahead and render that again, and you don't see too much difference. Our renderer includes intersections. That's so that the rendered result is a little bit different, but if you're not really paying close attention, you might see that it looks very much the same or exactly the same. And so what's the difference? Well, here's the difference. What I'm going to do is turn off Freestyle. Although our renderer is using geometric objects as the source, Freestyle is still enabled, and as long as it's enabled, it's actually active, whether we're using it or not, whether you can see the result or not. So if I turn this off and render again, you'll see how much faster this is. And in fact, if we want it even faster, what we'll do is we'll turn off output to this window here, the Blender Render Preview window. It turns out that writing to this window is very time consuming because each pixel is 4 32-bit values that we have to write. And so the bigger this window is, the slower the rendering into this window is. But what we could do is with this option here, we can stop output directly to that window completely. And when we run this again, you see the rendering is even faster, and there's just basically no output into this window at all. The window still pops up, but there's no output. So that gives you the fastest rendering. So now with this scene, I'm going to call your attention to one more thing, which is this line up here that's flashing. You'll notice that in each next frame, this line appears or disappears. And this is kind of a classic problem with renderers, especially laser renderers, but it happens with regular renderers too, which is what's happening here is that this box is sitting precisely on this plane, and due to 32-bit rounding errors, sometimes it's calculated as touching the plane, sometimes it's calculated as beneath the plane, sometimes it's calculated as being above the plane. So we have a few solutions to this. One is that there's a checkbox here that says prevent intersection flickering. When you check this, we'll render again. And now you notice you don't get this flickering line anymore because we changed the method of rendering slightly to just prevent this kind of flickering. I'm going to turn off this option though. I'm going to show you a different way to do this just to demonstrate why this is happening. And what I'm going to do this time is move this box. So I'm going to click on the Move tool, click on the box, move it up just a little bit. You don't have to move it much, just so that it's not precisely sitting on the surface. If I render this again, you see that now there is no problem there. I could also move this down slightly just to make it definitely below the surface, and the same thing will happen. So this is a couple of solutions to this. So the purpose of me going through this actually is to show you not only the example files that we're including, but also some of the pitfalls and gotchas that you may run into and how to solve them. So that concludes my demonstration of freestyle options. The next thing I'll demonstrate is that this plugin supports lighting, shading, shadows, and textures. Go ahead and render this. And so what this is I've got this red box sitting on top of a white plane, and as I move the frame slider, you see this little star looking object. That's a light source. And what we're doing is we're just moving the light source around, and you can see that it will cast shadows, it illuminates certain faces of the cube and cast shadows on the plane below. So you can use this technique in your own laser programming. It adds just another level of dynamism to the artistry. Next thing I'll demonstrate is this texture. What we have is this kind of default Blender cube on which we've mapped this Microsoft Windows kind of texture, Microsoft Windows logo. If I render this, you see that what we're demonstrating is we're capable of picking that texture up. And to do this, you don't even have to do anything special. We can come down here into the object's color settings, and you'll notice that there are no settings needed to pick up the texture. As long as the texture is there, it will be picked up. Now there is one thing I'm going to call to your attention at this point too, and it's this. If you look really closely at the Blender render window, you'll notice that this is a slightly different shade compared to this. And here's why. This is going to help me to demonstrate what you need to watch out for. It's this thing down here called color management. In the render tab at the very bottom it says color management. If you want the Blender render window to show what laser is really going to look like, you need to put the view transform to raw and make sure exposure is 0 and make sure that the display device is sRGB. When you do that, then the Blender result will be exactly like the laser. All right, so moving along, what I'm going to be demonstrating now is something called Grease Pencil. Grease Pencil is a 2D, it's a way to include 2D strokes and 2D artwork into the 3D environment of Blender. Now, one of the things that's so exciting about this is that the line width of these strokes and these the line width of these grease pencil strokes can be variable. As you see, this is a graffiti looking image, and the great thing about it is that we can carry this right through to beam brush, and that's what we're doing here. So as you can see, we have beam brush up there, and we can control the amount of brush. What I'm going to do is click on this pangolin graffiti thing, come down here to the beam brush settings for this particular object, and increase the amount of brush that's happening for this, maybe 25. And you can see that you get more brushing action out there. And there's something else I'm going to show you, which is this. If I come on the object, what you see here is these lines what I've got here is this plane up here, and I told the plane that I wanted some contour lines to be on it. I'll go ahead and turn on interactive rendering just so that we can see that a lot more quickly. Let's see. Yes, I clicked on the plane, and so you can see that I can basically put these contour lines. So basically the purpose was for me to see this, and this is the kind of the classic laser thing of you've got two different things, but you know, they're both up there at the same time. One of the things I want to show you is that Grease Pencil has some hidden line capability to it. So if I click here, I'm going to click on the object, and I'd say I don't want it to be transparent, but I want it to be non-transparent. And now the Grease Pencil is actually on top of the plane, and you can see that there is some hidden line removal going on between the Grease Pencil lines and these lines in the background. So now this is not perfect just because of the way that the hidden line removal works with Grease Pencil with Blender. But nevertheless, it is useful. But I want to give you one word of caution here, which is this. If I turn Beam Brush off, one of the things that you'll notice is that the lines are now small, and that action, this kind of carving out this hidden line removal works a lot better. It's a lot more faithful. But as I enable Beam Brush, and even if I make that Beam Brush even bigger, like this, the hidden line removal does not really become aware of the thickness of the lines, and so that stays. So nevertheless, it is a really cool thing, this hidden line removal with Grease Pencil. It's not perfect, but it is something. It's something that's there, and it's something that is available to you. So I'll give you a demonstration of something else with Grease Pencil here, a similar scene. And here what we're demonstrating is the ability to use lighting along with Grease Pencil. What I'm doing is, here's it gets this light source here, and as I move the frame slider here, what we're doing is moving this light source back and forth. And what you can see is that we are able to use Grease Pencil along with lighting. Now the reason why this is so remarkable is because this is really atypical. What I'm going to do is switch the renderer back to Eevee, which is a kind of classic renderer in Blender, and I'll render this just to show you what it normally would look like. What you see is the spotlight moving on the plane, but it doesn't really influence the Grease Pencil. So in Blender, there's no direct way to use lighting along with Grease Pencil. From what I've heard, there's kind of a hacky way that you can do it. But what we do is we've really taken this a step further in Lasershow Converter, and we allow you to use the Grease Pencil directly with lighting. And you're going to be seeing that in some of the other examples. So as I mentioned, we had hired a couple of artists to play around with the plugin and say, hey, play around with this thing, let us know what you think, let's see what you do with the plugin. And one of the people was a guy named Sean Weller. We were so impressed with what he did, we actually hired him. But nevertheless, I want to show you the very first thing that he did, which is this. So it's pretty cool, and for the very first thing he's ever done in Laser, it's pretty cool. But here was the thing. I said, okay, Sean, here's our plugin, play with it. What I didn't tell him was that lasers have kind of a point count thing, and so this scene is so complex that you get lots of points here. And so the point of this demonstration is for me to show you that it could be that you're out on the internet or somebody gives you a file and it's very complex, and how to simplify that for laser. So the very first thing I'm going to concentrate on is the particle system that Sean used to create this kind of the smoke behind the tires. And it uses this one seed sphere as kind of a seed. And so when you adjust the line types on the particle, you can't click on the particle itself, you have to click on this big sphere. And so what I'll do here is say on this particular object, and just like in our 3D Studio Max and Cinema 4D plugins, you can change things on an object by object basis. So I just clicked on the sphere. We want to say the Lasershow Converter settings for that sphere. What we'll do is we'll say the line types. We only want to see the very outline, and not all the other things that might be going on there. And in addition to that, what I'll do is come over here to the filter. What we can see here is that we get some sublines. I'll show you here in just a second. So now that it's a little bit better, but we've got some what I call little kind of sublines in here. These like little pieces of lines here and here that show up as a result of this. And so in the filter settings, what we could do is we could say we don't want to see anything smaller than 10 beam diameters. Everything here is specified in beam diameters. So any really short little specky things is going to be eliminated by that. We'll render this again. So that has helped a lot. We've gone from 5,000 points down to maybe 4,400 or so. So the next thing we'll attack is this grid. I'm just going to click on the grid and I say for this grid, I just want to see, again, just the outline. I don't want to see any other type of thing. We'll go ahead and render that again. And you can it still looks cool. Still you see it's a car on a kind of a plane with some smoke behind it, right? So the next thing, what I'll do is, see how it got all these little spokes inside the wheel? It looks cool, but it just takes up a whole lot of points. So I'm going to click on the wheel and I'll go into the object settings and say I only want to see the outline of the wheel. I don't want to see all the little details inside the wheel. Let's see how that looks. Yeah, and that's good for that one. I'll click on this one and do the same thing. And now we're down to, maybe 2,000 or so points on average. And if we want to do something further, what we could do is click on the car itself. And all these tail lights and stuff like that were shown up as a result of what's called material change. So if I turn off material change, and maybe intersections as well, we'll render that and see how that looks. Now we've lost the tail lights, right? So this is just a demonstration of how to reduce the complexity of these things just by adjusting some of the settings on an object by object basis. So after some instruction from me of saying, hey, we've got to watch this point count thing, here are the next few animations that Sean did. He made a sparkler. Pretty cool. And also made this pumpkin thing. And you can tell what time of the year he was working on this. Again, pretty cool, directly usable in laser, perfect, right? I want to show you one more thing on this. I'll tell it to go ahead and output to the Blender, and we'll render this image here, maybe come out here to here, because this is, once again, if you take a look, there is a difference in the coloring from this one to this one. And once again, what we would do to solve that is come down here to color management and select raw. And then when we render that, the Blender render window will give us exactly what the laser will. So the next thing I'm going to show you is really cool. Sean is a seasoned user of Blender, and he uses geometry nodes and shader nodes and all kinds of stuff. But he says, hit play on render to hear the audio. So what he's done here is he's taking the waveform of this audio and manipulating this kind of piece of spaghetti with this. And I'll go ahead and render that just to show you what it looks like. I'm going to press escape to stop the rendering action. I'm going to render the whole thing right now, but so it's rendered up to here. So it's pretty cool, but how can we make this better? If you notice, the laser line actually consists of a line above and a line below, and it's not too bad, but if we wanted to turn this into a single line, we can do this. What we'll do is use one of the filters, what we call the overlap filter. Change the filter, and we say because it's such a simple geometry. You say, I don't want to see anything. If anything is within 10 beam diameters, just get rid of it. In fact, we'll change the angle to 45 to just make that a bit more aggressive. We'll render that again and see what's happening. And now you can see that we're down to a single line. But the result isn't perfect, because in addition to having our single line, it's sometimes when the angle becomes too sharp, it's not really an overlap, but we get these short little peaks out here, and we'll use what we call noise filter, the thing that strips out short little peaks. And we say if anything's shorter than 10 beam diameters, just get rid of it. We'll take a look at that. So now you can see that we have our single line with no additional short little lines up there up top. So that's worked out pretty well. Nevertheless, can it be made better? We'll see. So I've stopped the rendering action here. And let's see, we'll go into geometry nodes. And what you can see here is exactly how Sean has created this thing. You know, and he's a real master of this. So it's got all kinds of stuff going on. And nevertheless, let me see if I could figure out. So what he does is he takes this curve and he resamples it and he turns it into geometry and turns it into a mesh, and then voila, you got a piece of spaghetti that dances to the beat of the music. But with this, it has really a very high polygon count, and what we could do is this thing here that says count, we can reduce this to maybe even 500. We'll try that. You can see it renders a lot faster now because Lasershow Converter Blender doesn't have to go through all of these polygons to generate this, and the result is certainly no worse. So I don't think it is. Let's see. Close this. Go back here to animation. There you go. And once we're happy with it, we can just, since we could either say send frames to beyond, or since this checkbox was checked, it will automatically send it to beyond. There we go. So another artist that we had is named Davor Druselic. He's from Eastern Europe, and he generated several things. So this is the very first thing that he sent us when he was playing with the plugin, and I'll show it to you. Go ahead and render this. And this is kind of a very classic laser thing to do. You got multiple geometric objects moving around, kind of highly applicable to laser. And so, you know, I thought that he really kind of got it, what the plugin would do, what you could do with it. But nevertheless, when he sent me the file, I noticed some problems. One of the problems is that this window was just so much darker than this. And we've already discussed what kind of the solution for that. We'll come down here to color management and make sure that this is raw sRGB and that the exposure is 0. And when we do that, we'll try this again and notice that this is lightened up. But nevertheless, I mean, this is a simple scene. It's just got a very simple geometry. So I'm wondering why it is that our renderer is taking so much time with this. What's happening with our renderer? Our renderer is blindingly fast. It shouldn't be taking this much time to do just such a simple scene. And so when we looked into this, this is what we found. Up here in compositing, Davor is a professional Blender user, and this is something that he does a whole lot, is uses this compositing stuff. And compositing happens after the whole rendering operation. And so he's got this denoising thing, and this takes time. In fact, it will take even more time the bigger that window is. I'll come over here to render again just to show this. See how slow that is? I'm going to hit escape. And if we make that render output window even bigger, you'll notice now it goes really slow. And again, the reason why is there's so many pixels in here, and every single one of those pixels got to go through this denoising operation. So the answer here is to just remove this denoising. This is not needed for laser. It doesn't help anything, and I will take the image output here and just put it to composite. And now when we render, I'll go ahead and make this small again too. You can see much faster. You also may notice that this window here, it doesn't really keep up with the laser preview window. And that's because Blender refreshes this window at a different rate than kind of real time. And so sometimes you may see weird blocks in here. You may see partial images. This has nothing to do with our plugin. It's just the way that Blender works. And so the point of this is just to show you, you may see and find things up there on the internet. You may receive things from customers that these are things to watch out for, because the professional Blender users use compositing and a whole lot of other things that may slow down the laser rendering option and do not really add anything to the laser. So here are some of the grease pencil examples. One of the things that I had Devore do is really play around with grease pencil. And we'll go ahead and render this. And what we see is that you can use grease pencil to do this classic thing that we do in laser all the time, which is this kind of write and erase kind of effect. But in addition to that, what Devore has done is moved these light sources. He's got a red light and a yellow light that he's moving with time while he's doing the write out operation, and it just really adds something special to this. I'll show you a few more of these. So again, this is back to grease pencil, and this is a simple plane, and I wanted to show a couple of things with this demonstration. One is we see this plane that's mostly blue, but it has kind of a pink wing and an orange wing here. And there's a very special capability that Lasershow Converter Blender has, and that is, so I've already talked about how there's these, what we call the default settings. These are the top level. These are the things that take precedence unless they are overridden on an object by object basis. And they can be. Each separate object can have its own settings here in Lasershow Converter Blender. Now, the Blender plugin, we have yet another thing that can take precedence, and that is each one of the grease pencil strokes can have its own Lasershow Converter Blender settings. So this just gives you a tremendous amount of power over the lines that are used, the color, point spacing, beam brush on each stroke in the grease pencil output. You have this kind of control, and to help you to see which one you're working on, you can just click on these buttons around here. And so this is the wing here that's kind of orangey, so I'll turn off the custom color settings for that. And as you can see, since I have interactive rendering enabled, this immediately changed. We'll go about finding that wing. So this is that wing, so I'll click on this one and to turn off the special color for this, and now we have our completely blue plane. So it just goes to show you the power that we've provided here in Lasershow Converter Blender. Each stroke within grease pencil can have its own settings. And I'm going to demonstrate one more thing to you, which is pretty important to understand. Let's see, was it this one? Yeah. Let's see, I want to change this to here. Yep, so there we go. And it's this. So clearly, Lasershow Converter Renderer gives you a lot of power. It gives you the power to change the settings at the top level. It gives you the ability to change settings and apply settings for each object in the scene. And then furthermore, each object may have strokes that are further controlled, right? So it could, with all of this control at each level, it may be hard to tell. Like if I come up here to beam brush, let's say, and I say I want the beam for this to be 20, to be 50, right? So, but now let's say in the propeller, I'm going to go back down here to the grease pencil strokes. And on the propeller, let's see, what is that? Let's say on this wing right here, what I'm going to do is override the beam brush on that one and say we want no beam brush on that. Right? So there could come a situation where you're up here kind of messing around with things and changing the color. Let's say I want to use a custom color and change the thing to red. But wait a second, you got a couple of wings here that aren't red. You say, I want the beam brush to be this, but wait, we got this wing over here which has no beam brush at all. What's going on? And it could be kind of frustrating to kind of fish through which objects are overriding me and which things. So for that reason, what we have is a feature in here that will show you, it gives you some additional information on this. It's what we call Object Settings Precedence List. And it's at the very bottom of the Lasershow Converter default settings here. When I expand this, what you'll see is a list of objects and what may be overridden on this. Like for example, here we say the plane is the name of the object and it has a lowercase c and a lowercase b. The lowercase c means that the color settings, and everything is just based on these letters here. So if we had a line type that was overridden, it would be an L. If it was the color that's overridden, it's a C. If it's the beam brush that's overridden, it's a B, right? And now what's interesting here is it could be a capital B or a lowercase b, and it's because we needed a way of telling that it's the object settings or the grease pencil layer settings. And so now by looking at this, you can at least get a clue, oh, I see the plane has something overridden in the grease pencil layers of the color and the beam brush, and that's what's going on. So I'll demonstrate this in a couple of other places as well. So here's a bicycle. And what you see is the beam brush here, the beam brush effect. If we take a look back here in Object Settings Precedence List, what we can see is that the bike, each one of the wheels has the beam brush overridden. You can see this, and this is at the object level, and the bike in the substroke level, the grease pencil layer, we have some things overridden here in the color. So just to demonstrate this, I'll click over here to this object here that says wheels. We'll go here to this object and we can say that indeed this wheel does have a beam brush setting applied. I'm going to just turn this off. So now we have the default beam brush. Now if we come back here to the Lasershow Converter, you can see that it no longer has wheels. It only has wheels 1, which is overriding on the beam brush. If we come over here to bike, into the actual strokes of the bike, you could see that indeed we have the little hub part there and the frame part there. Each one of these has its own color setting. If I want, I can come up here and change this to something more dramatic, maybe this green. But you just have a tremendous amount of power here through Lasershow Converter Blender. And this Object Settings Precedence List can help you to understand where you should look to apply the settings for the actual output. So this is the last thing I'm going to be demonstrating. It's something that we've added just very recently into the plugin, and it's this. Blender has a capability called shader nodes, and it also has another capability called geometry nodes. The geometry nodes I demonstrated a little earlier, but with shader nodes, what you can do is you can create, you can take this actual geometry and run it through things and make it do apply colors, apply these colors and come up with a completely different shaded output compared to what would be possible even with texture. So what I'm going to do is I will turn this to the Eevee renderer and I will show you what this does. Only 5 frames, so I'll have to say more than 5 frames. Maybe we go 50 frames. If you take a close look at this, what you'll notice is that these blue and red are actually moving. Maybe we'll do more than 50 frames. Let's see, 100. Just so you can see that these things are moving around. All these colors are changing. And because this is done with shader nodes and not with a texture, we really can't pick this up with our renderer. You know, our renderer picks up textures, it works with textures, it works with lines and stuff like that. And so if I go to Lasershow Converter and just render this, what you're going to notice is it's just lines. You know, it doesn't do anything. It doesn't have a texture that we could pick up and put the colors on. So we have created a capability where what we can do is we can render to laser, and then we can render to Eevee, and what we can do is we can actually pick up the colors at each pixel location that corresponds to the laser and replace the original laser color with the Eevee output. And that's what I'll demonstrate right now. And that's done with this button here called Render Animation and Recolor using Eevee. I'll just click on that button and show you. And you can see that the frame slider here is moving along. These are the frame numbers that are being rendered. And if you take a close look in here, you can see that the colors are changing as the frame numbers are changing. Now this is a slower process because we have to render to laser, we have to render using Eevee, and then we have to combine these colors. But this is a way that you can take full advantage of all the capabilities in Blender and use the shader nodes to do this exciting coloring operation and all kinds of other things and capture this and actually apply it. Now if you want, you can let the whole thing render, or what you could do to stop it is click anywhere in here and then press and hold the escape key and it will stop rendering. Now notice as long as this other window is up here, the Blender render window, if you just hit the escape key goes to that window. It's Blender, the program, that needs to hear the escape. So it's just click somewhere up in here and press and hold escape. So now when we move the frame slider, what you can see is that the colors are indeed changing. Maybe this isn't a great example, but nevertheless, you can see that what we've done is we've picked up the colors from the Eevee rendered result and placed them right on top of the laser. Now this is another area where this comes into place, this color management. And in this case, since we're getting the colors from the Blender render window, this is really important that you set this in a way that captures the colors the way you want to. If I change this back to 1, one of the things that you'll notice in Eevee is that this is now very dark. And if we try the overlap and recolor, this is now also very dark. So everything kind of plays into this. The shader nodes, the color management, they all play into this particular model if you want to be using this feature. I've got a couple more things I'm going to demonstrate along these lines. So once again, I'll render this using Eevee first, just so you can see what it's supposed to look like. It's basically these two spheres, each one of which has this special color operations going on to create the colors of the spheres. This is not a texture, it's an actual thing that's generated. And because it's not a texture, we cannot pick this up with the laser. What I've done is I've thrown some contour lines on here just to show. We'll render this in laser, and that's all you get is a bunch of lines. But once again, when we try this render animation and recolor using Eevee, what we can do is we can actually sample the colors here and pick them up. So in order for this to work, what you've got to do is this. For the particular object you want to use this feature on, you have to use this option here called Recolor using Eevee. Normally this is set to none. When you want to use lighting and shading, you can click in here. You have to select this to recolor using Eevee, otherwise this will not work correctly. And you can do this on an object by object basis. And there's one more thing I'll show you, which is notice how this has that white, kind of surrounded by white lines here. If I change this, basically surrounded by white lines. What we can do is if we go back up to the Eevee renderer and click on the world, this is the background color that will be rendered with Eevee. So once again, I'll just render a single frame here. You see it's got a white background. If I change this to a black background, like this, now you'll notice it's got a black background. So when we now use this combination in Lasershow Converter Blender of render, animation, and recolor, you'll notice it no longer has the white background, and in fact just picks up the colors better. So this is just another thing just to be aware of when you're using this particular feature. All right, there's one more example I want to show you that takes advantage of this capability. It's this file here, stars. I'll go ahead and render a single frame of this just to show. If we render this on laser, what you get is just the lines. We can't take advantage of any of these colors because all this stuff was done with shader nodes. It wasn't done with textures or colors. So we can get the lines, but we can't get the colors. So what we're going to do is use that same technique of render and recolor. I'll go ahead and click this here. And I'll show you the scene first. It's really cool. We've got kind of like stars. It's like the view through a ship. We've got these stars coming through, and at a certain point in time, we reach light speed and go like this. And if I render this to laser, I will render this to laser just to show you when we come to the light speed part of it, what it looks like in laser is nothing like what it looks like in that window. So we're shifting here to light speed, and there you go, a bunch of lines. I'll stop the rendering operation here. And we'll go ahead and press this render, animation, and recolor using Eevee. And now it will be able to pick up the colors. So I'll go ahead and stop the rendering action right here just by pressing escape. Click here first. And there we go. You can see that we've been able to pick up the colors, pick up this part that went through light speed. And so this is just a very powerful tool that lets you take full advantage of everything that Blender has to offer. So this has been our demonstration. I hope you like it. If you have any questions, please send them to support@pangolin.com. Otherwise, we hope you enjoy the plugin and wish you happy lasing.